So I've been doing these streams, programming streams on Twitch for the last couple of months, and it's been a fun format. I've had a couple of viewers watching, but I figured for programming, if I really want to concentrate, it's probably not best to have like a chat box open, and it's fun to interact with people real time while you're doing it and getting that feedback. But I think for content like this, just me programming, it might work better to just record directly with nobody bothering me. In fact, let me disable notifications before I forget that. And just uploading directly to YouTube. That way, maybe more people can watch it and then comment down below instead of real time. And Twitch does delete recordings after a while, which is kind of annoying. So if you don't stream for a while, they just delete those recordings and it's like nothing happened. So they're kind of lost forever. I do have the recordings stored on my disk. The idea originally was that I would stream a lot and then at some point edit all that stuff into videos and then put it on YouTube. But I figured it would probably work better to just do a dedicated recording here. So that's what I'm doing now. So the project that I'm working on is my little rendering engine here, C-Ray. It's not really a creative name, but it's basically a CPU path tracer that draws pretty images, hopefully, at some point. Right now, this is about the best it can do, this trooper image. It's just a very simple set of materials and simple lighting. It happens to do pretty well with that. Here's a little test render. And if you're not familiar with path tracing, the idea is not that it's like real time. It's just offline, basically. A render can take up to like hours. So the idea is like visual fidelity instead of speed. So the thing today that I figured I'd try and tackle is, well, I guess it's better to show it, but basically there's a really long warm-up time, but only if I have the SDL window enabled. So let me show you what I mean. So if I just invoke it normally, it's built through here. So that's a command line program. So basically you just invoke it from the command line. So we invoke the binary, and right here we can give it an argument of where it loads the configuration file from. So here we go, input /statues.json. You can specify dimensions and sample counts, and there's you can do like -h to get all the options. But anyway, let me just do statues. We'll do 100 samples. So this is how you'd normally use it, and then you get a little SDL2 window here showing the render preview. So you can see how it's going along. Let's reduce the sample count, make it like 10 samples. That way it's a bit faster. So there you go. You can see kind of drawing out the image. You can see the real-time feedback right here of what it's doing. And that's all fine. So for a long-term, like a long-time render, it's fine like this. But the issue that I discovered a while ago is if we just make this like not even render anything, we'll just make it like, so this is where it actually invokes the rendering stuff. We'll just return white color or whatever. So that way, let me rebuild. Yeah, we'll do HDR and one sample. That's just a different scene, basically. A configuration file is essentially the scene description. So there you go. That was pretty fast. You barely saw it, but if we open up the rendering resulting image, there you go. It's all white, like you'd expect. That took 408 milliseconds, and that's only for the rendering. So the actual scene setup is timed separately. So that took about a second, and which makes sense. There's some, there's a lot of textures to load. There's some meshes to load, and it has to compute acceleration structures. That makes sense. We can profile that later and kind of make it a bit faster, maybe. But we're not going to worry about that right now. But what I'm worried about right now is this. It took 408 milliseconds to render that image. I don't think it has to take that long. So let's see what happens if we build it without SDL2. So you don't get the window. It just does it internally and nothing. You can't see anything, but it does the same thing. So we can do that by rebuilding. So you can give it this option, no SDL2, set that to true, and then rebuild. That takes a couple seconds. And then we'll just do the same invocation, right? No different, same settings. See how long that takes. 32 milliseconds. So there's quite a bit of overhead in setting up SDL2, and I don't think that has to be the case. Now, what weirds me out is, let me show you here. So when we do, let's go to main. Let's just start there. So we set up some stuff, you know, in it renderer. Then we load the scene, and essentially this is timed. I think it's in here somewhere. Yeah. So load scene basically starts up a timer, and then it parses the JSON, does a bunch of setup. This is where it computes the acceleration structures for rendering. This takes a while. And then at the end, where does it actually print the time? Yeah, there we go. Print scene stats. This is, I think, yeah. Scene construction completed in, you know, whatever, milliseconds, 32 milliseconds, and then it gives them some totals. So that's timed separately. So this prints out, what is it? 1.101 seconds. Okay. Then we actually call out CR render single frame, which just basically renders an image into an internal buffer. So in here, we call init display, which is the only part here before the rendering that actually does SDL setup, which can take some time. But notice how we start the timer after we set up the display. So in init display, if you don't have SDL enabled, it's just a no op. It doesn't do anything, right? You know, it just, you know, mute the warnings and print the message that, you know, render preview is disabled. This is not going to take 400 milliseconds, I'm pretty sure. But then we start the timer, render the image, and then print the duration, which is 32 milliseconds, and up here was, what, 400? That's ridiculous. So let's profile this before and after. I think we can use the, let's see here, is this configured right? Let me just make sure that the stuff is set up right. So let me do the same settings, hdr.json, right? What's it? Yeah, hdr, and then samples 1, and then whatever. These don't really matter. Dash T sets the tile size that you see. Dash V is just verbose mode. We'll set those up, right? And then we're gonna have, yeah, we'll have a debug build or whatever. Let's just run that and see what that gives us, like a baseline reading. Eventually. There we go. I don't know why you got all these spaces here. There you go. So it took longer now. And this is without SDL2, so because this is in debug mode, I think. Is it? No, actually, we have SDL2 enabled here, right? So that's why it took so long. But it's a bit slower anyway, because we have the debug mode enabled. So let's profile this, see what we get. So we'll have the, I forget, I think this is based on dtrace, if I recall. This is the Xcode instruments thing, and I think it's pretty neat. It's like a sampling profiler. So we'll do a time profile. And hopefully it didn't forget my arguments. Did it? This might require some finagling to, yeah, it did forget my arguments. What was it? Sample 1, and then 16 by 16. Yeah, we got the right directory. Hopefully this works. Sometimes it just doesn't. The environment's all weird. It should just copy whatever you have going on here as the base, but whatever. So we'll do that. There we go. Making sense so far. It's building the BBHs, which happens again before rendering. And then, yeah, there we go. We stop. So that makes sense. And in fact, we might actually, this is quite a bit of noise for the profile. I just realized. Let me dump this. Do we have like template? Yeah, what do you have? There you go. Now we don't have anything in here, so we're gonna use the template instead. Let's redo this. See how long it takes here. Template should just be, yeah, it doesn't have anything and we still get the white image. Yeah, it's got nothing in it. So where do template, whoa, template, no. There you go. That, see that gives us, yeah, still 434 milliseconds, that's not right. Time profile. So now we don't have the noise, hopefully. Let's edit this. Template. Record. It shouldn't take too long. There you go. So it's been a while since I used this. Heavy stack traces main, which makes sense. Build BBH, which it shouldn't be doing much of anything here. Why would it do that? Hold on. Compute top level BBH. How does it use that? Okay, so we're gonna maybe optimize some other things as well. All this happens before we actually do anything, do the render. So we don't really care about it, but it still is interesting how that takes 190 milliseconds of the execution time. Because there's nothing to compute it for. So obviously, yeah. So see our right image. See our render single frame. Render frame. That takes a millisecond. So let me look at the code here. So render single frame. Render frame, like there's not even, it doesn't even show up this in a display call here. Which actually, hold on. Did you even use the thing? Is this with or without? We didn't see the window even. What's going on here? Edit. Is it even the right version? Is there like a... I don't even see a terminal. Where's the... It's debugging a binary. I don't know which binary that is. 27th July, 2344. Yeah, so it's the one we just built. Okay. But that one should have the STL enabled though, right? I think we can actually, yeah. What was that? Template. Yeah, it does have the STL. I just didn't see it. Maybe I missed it. Did I really? I thought I didn't see it. Maybe I'm getting confused. Executables. Right, it's story build. Okay, I don't know. I kind of want to look at this though. Compute top level BH. We're just gonna get confused here. So instances, instance count, and I don't think we have the instance count. Right, so we actually go into build top level BBH. Then go to build BBH generic. What's going on here? We malloc a lot. Why do we malloc? So we never actually check the instance count. So we're just assuming there's gonna be instances and then we do something. I mean, apparently we do quite a bit of allocation there. That's crazy. Can we do like invert call tree? Just go to the root. See what's actually, let me hide system cramp because I don't care about that. Yeah, okay. What is color tree get? Right, this is the PNG compression. Okay. I think we're building an idea of what's going on, but I don't think this binary happens to have the STL enabled. Doesn't look like that. So we would see it here. What happens if we just stub out that call? Let's just make sure that that is actually the thing that's slowing us down. So just quickly here. Yeah, like that. Now it should be fast again. Actually, we have to enable STL2. And rebuild. There we go, 30 milliseconds. That's about what I expect. I'll redo this. Just sanity check. There we go, 408. Okay, so I don't think that our profile had that enabled somehow, but we'll find out. Because this one had it, right? If we run it here, this one has it. Let me just add like a print so we can, well, since the instruments doesn't have a console, does it have a console? No, that's not at all what I was looking for. DuckDuckGo. Let's play the console. See the screen. Okay, yes. Okay, sure. It was easy enough. Console. Boom. Okay, so render preview is disabled. No SDL2. Okay, I don't know how that happened, but okay. That's kind of weird. I think we might have it defined somewhere. Hold on, let me see. Display here. See where this is referenced. KFDef. Okay. Ah. So we got preprocessor stuff. What, actually, where is that? So debug. Maybe it's using like a release thing? I don't understand that. That doesn't make sense. Yeah, we include STL2. Let's fix that thing with the. While I think about that. Do we have any run issues? No. Okay. This guy, build BBH generic. What should we do when we don't actually have any instances? Could we just how do we actually do this in here? So we build BBH generic, and here we could check, like, you know, if the account is listed. I don't even know what it does, to be frank, when we have like no instances. Yeah, account. So we allocate centers times 0. Okay. I don't know what happens if we pass 0 to malloc. I'd assume it returns null. We can find that out. It's not null, okay? Wonder what it returns. Like a pointer to 0 bytes, but it's not null. If successful, yeah. Pointer is not null. This is all about like if size is 0 and pointer is not null, a new minimum size object is allocated and the original object is freed. At least with realloc. Okay, I don't know what it returns. It returns a pointer, evidently. Okay, whatever. So we allocate, 0 pointers, b boxes. But so what do we return? We return a BBH. Node count 1. I think we just return a BBH with a node count of 0. Maybe? Right? So if we do like top level BBH, node count is equal to 1. We'll add a special case if BVH node count is less than 1, return false. We don't even need to touch that. And then we can just on here if count is less than 1, we do like BVH node count is 0. I think we just return here, right? Earlier more. We're gonna throw away this. Don't save. Profile it again. Cool. Don't know why it doesn't have the STL. That doesn't make sense to me. What happened here? What happened to my parameters? Why would it do that? Input template.json. Oh, it just went to a random directory for some reason. Oh, why did it do that? Like, we have the debug one selected. Maybe I should be using profiler, maybe. I don't know. Debug, profile, and then we always have to verify the parameters. Because reasons. No, you don't want to be there in the release. These are okay. Record. Show this. I thought I hit record. There we go. Did it actually output a file? Yeah, it did. Yeah, 691 bytes. Okay. Yeah, 59 milliseconds. That's not what we're looking for, but let's look if it helped with this. Can we invert the thing? Hide, invert, main thread. Yeah, so now we only get basically the PNG encoding. And we don't care about all this crap. Yeah, okay, so we basically eliminated that. And let's make sure it still works though. Assertion failed. And also, let's make sure this is like not like that. Still works. Cool. That's pretty good. So we shaved off quite a bit of the execution time. Let's actually, we should have timed this as well. Recompile that. We want the template, right? 768 milliseconds. And then we can yoink the old optimization here. Yeah, 1.16. You know, it's a speed up. That's cool. Hold on. Yeah, VVH. Yeah. Let's see. Don't compute BV. Top level of BVH if there is nothing to compute it for. Whoa, I don't know what the ret means here. I think it means we went over our column limit, but it still does it when we wrap it. I don't know. I don't know what the limit is. Yeah, it still does it if we cut it. I don't know what that logic is all about, but anyway. Okay, so that's that. Now we gotta figure out why we don't have STL2, even though we should. Why do we not have STL2? Right, it's disabled. Quite obviously, it should not be. Edit target. Environment variables. None of these are relevant. What is this? Okay. We built that very recently. Right, and this one has, you know, STL2. Why does the profiled one not have it? Why would it not have it? Again, it fucked up the path. Why did it do that? This is a debug build, first of all, and that is not the right path. It's trying its best, I guess. Yeah, disabled. That ain't right. Also, it crashed. Somehow. We'll just go ahead and ignore that for now. Why? This is Xcode fuckery. Maybe we should just build it by hand and, you know. Yeah, I think we'll just build a binary. Debug. Right? We're gonna profile. Let's see. Bin C array. There we go. Working directory. No environment variable. Oh, no. Wait, we got arguments. Put template.json. That's one. No, it's T. Keep forgetting. There we go. Choose. Record that. There we go. That's more like it. Okay. Now we can see what actually happened. Time profiler. Invert. Main thread. Okay, look at that. So again, you know, we do all this stuff to set up the SDL, so this makes sense. There's a lot of stuff to set up a window, but let's not invert this. And we're gonna go here into render single frame, which, yeah, it takes a long time. In a display, takes a while. But render frame takes 56 milliseconds, right? It's the same. I don't remember what it was before, but do we have the previous run? Yeah, we do. I think this is it. Main thread, main, render single frame. Yeah, render frame took 1 millisecond. Okay. Maybe that's not a valid run. We'll do another one. Right, so render frame take, well, anyway, we don't record this time though, so I showed the code already. We start the timer here. Maybe we're using the timer before and we don't reset it. Alright, start timer. Timer catalog. Yeah. So we zero allocate it, which is fine. And this is the first time we're using it. I don't know. It's just a, you know, time val. Let's do another run. So just so we can compare them. True. No SDL. And rerun this. There we go. So that's without. Why did it crash? Does it crash here? What was it? Same options. Okay. Why does it do that? And what does not do it here? What? Hold on. Let's just template S1 T1616. Okay. What? Run ascent on it. I don't know what's going on here. Heap buffer overflow. What happened here? That didn't happen before. Load file. 27. Yeah, we allocate a buffer. Len and 32. Oh. How did that not manifest before? Okay, now that's, yeah, that could be something we caused, but how did this not happen before? Isn't that kind of weird? I mean, we're null terminating it. That's kind of weird. I don't know what's going on there, but okay. I guess we fixed the bug. It just didn't happen before. I've done a lot of testing, but whatever. Destroy BBH. Let's see. That is on line 46. 46, free BB. Okay, yeah, so we gotta just check. Yeah. This assumption is no longer valid. Same for this one. we actually need to amend that. As part of the previous fix, because that, yeah, we forgot that. Okay. What happened now? 46. Destroy scene. Destroy BVH. Scene C176. What was it? 176. Top level BVH. Okay. Is it null? Segmentation fault. I thought this would do it, honestly. Also, how did this crash before? I tested it, I think. Yeah. Bye 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 bye. I kind of stumped as to why this would. I mean, I assume BVH is null, so when we try to dereference it to get nodes, but again, we check for BVH not being null here. That doesn't make any sense. Are we absolutely sure that that's the binary that gets built? See, what happened there? It just rebuilt that translation unit. Okay. We have a bunch of... Okay, it still didn't work. Okay, fair enough. What? 46. How could this crash? 46. BVH nodes. Which implies that this is not null. And that this is not null. Then we free it. Fault was caused by dereference of a high value address. Disassemble the provided PC to learn which register value was used. What? That doesn't quite make sense to me. Like, if there was a null pointer here, I would see it, right? We check, then we check again. And how did this not manifest before as I was trying? Maybe I just missed the crashes. Yeah, I did click once to hide the, ignore that for now. Rebuild, release. What happens then? Because I swear I saw it run, without problems. Yeah, okay. So, yeah. Pointer being freed was not allocated. But why would that be allocated, though? Whatever, we'll just allocate these two. So, BVH, no, generic, please. Right, BVH, node count. Nodes. Whatever. I guess 0, right? That's kind of derpy, though, right? Maybe we just set it to null. Trim indices to null. Yeah, okay, yeah. I think that might, yeah, that helped. Okay, yeah, so usually I tend to use calloc myself, because it just, it's a bit of a waste to zero that memory every time, instead of only when you need it, but yeah, that kind of tripped me up, yeah. These were just garbage values, basically, and yeah. Okay, we'll append that fix as well. I think I didn't push. There we go. Okay, so that's done now. Let's get back to what we were doing. So we have these two runs. And did this crash, right? And the run doesn't really matter. Anyway, 59 milliseconds. Right? In here, see our render single frame takes 1 millisecond. Okay. And then in the run with SDL2, render frame takes 56 milliseconds, which is nowhere near. I think the discrepancy in these values is because this is a sampling profiler, so it doesn't actually know strictly how much execution time that took, or how long it took to run that. It just knows the proportion of, yeah. I think because this is not, obviously 400 milliseconds. Why does it take that long though? Get keyboard input. Draw window. I think. Yeah, still update texture. Okay. Wait. Which one of these runs was the one without SDL? Right, this is the one with SDL, and we want to find out why it's so slow. Oh, wait, what? Yeah. Yeah. Yeah, that's what, because I thought that this should not affect the actual rendering loop, but evidently so. We go in here, and we actually go into the render frame, which sets up the texture and a bunch of other shit. It sets up the threads. Then it goes into while loop, basically while it's rendering, while all the threads are running, it runs get keyboard input and draw window. Kind of forgot about that, because if get keyboard input, if SDL isn't enabled, it only does checking for SIGINT. Otherwise, it checks the event. This doesn't take too long, but draw window definitely does. Right. So I was under the impression that these hundreds of milliseconds were because SDL was initializing and somehow it was doing something odd in the render loop, but it's actually normal what we're seeing here, because we do call this draw window, obviously, and this takes time because it's copying a bunch of buffers. By the way, this implementation is not very good. We're copying the whole buffer every, what's it trying to do? Active milliseconds? 60 times per second, which is not ideal. I did try and work on a variant of this that would be a bit faster. There's an issue about it. I couldn't get it working, but I want it to update 60 times per second. I just don't want it to copy all these buffers every time. Okay, so I think that's the mystery solved. I don't think that there's much to do about that. I thought that was kind of sketchy, but now that makes sense. But we did manage to fix one thing, which is we managed to shave off, a bunch of time from building the top level BBH when there's no instances. So that's good. I don't know how long the stream is going right now. I think it's 30-40 minutes. So I guess that's it for today. We're gonna get push. And see if I broke the build. But yeah, I'll try and make more of these maybe if it works out. There you go. I got this CI system running here. It builds it. It doesn't do any checks yet. It just basically builds it on all the platforms, because I often break the Windows build inadvertently. So that's a check that it runs. You can do like testing is true. Now it builds in the tests, which are all in the same binary. And then you can do like, links, test. And the tests fail, of course, because I haven't done much work with these. It also crashes, but we'll worry about that next time. Thank you for watching. If you watched this crap, these first couple of videos are going to be pretty crappy, I'm sure. But anyway, thanks for watching. Bye.